In today's video, I will show you how to make a regular device smart using an ESP8266 together with ESPHome. The idea is simple. Many devices like fans, coffee machines or dehumidifiers only have basic buttons. By connecting an ESP board, we can simulate those button presses, read the state of the device and bring it to Home Assistant. In my case, I will be working with a dehumidifier, but the exact same approach can be used for many other devices. By the end of this video, you'll see how easy it is to give Wi-Fi control to almost any device in your home. The regular controls of the dehumidifier are the power button, the light button which controls the LEDs, and the mode button which switches between the built-in modes. Okay, now let's disassemble the dehumidifier. First, I remove the water tank. Underneath there are 4 screws, which I'd already removed. Next, I use an opening tool to slide it from the bottom to the top to release all the clips on one side of the casing. Then, repeat the same on the other side. Once both sides are open, I remove the back panel which is still held by a clip at the top side. After that, I remove 4 bolts which are holding the main humidity removal part. Once the bolts are out, I disconnect the cables. Main power cable, 1 from the fan and 2 from the cooling plate. This finally gives me access to the control board, the power board and a small board that has the RGB LEDs and the water level sensor. The control board and power board are each held by 2 bolts. Finally, I release the small board as well. And now I can take all of them out. To control the dehumidifier, we'll need few jumper wires and this little board called ESP8266 D1 Mini. On the sides of the board you can see pins labeled with D1, D2, D3 and so on. We'll use these pins to simulate button presses or to detect if the device is on by checking if one of them reads a high signal, around 3.3 volts. My board has a micro USB port, but it's also available with a USB-C port. To power the ESP we'll need 3.3 volts or 5 volts and the ground connection. On our board we have 3.3 volts and the ground connection here, and I will need to control these 3 buttons: on, off, mode and light. So I need to solder 3 wires here to the buttons and 2 more for ground and 3.3 volts. Before we start soldering, let's put a little flux on each pad. It helps the solder stick better and keeps the connection clean. Then put a small amount of solder on the tip and touch the wire with it to add some solder to the wire. This is called thinning and it makes the final connection much easier. Finally, bring the thinned wire to the pad and solder them together. Now repeat this for each wire. I will speed up the process here and then we'll move to the next step. While this is running, a quick safety tip. When using a soldering iron, I really recommend using a smoke filter or just opening a window, so the air stays fresh. Once all the wires are attached, you'll notice there is some sticky flux residue left on the board. This residue can attract dust or cause corrosion over time, so it's important to clean it properly. I take a cotton bud and gently wipe off the excess flux. To finish, I take a fresh cotton bud with a bit of isopropyl alcohol. It evaporates quickly, so it's completely safe to use. I hadn't planned to solder this wire later, but moving the camera around will be a pain, so I decided to do it now. Don't worry, I will explain later what we need this wire for and why I connect it here. Just like before, it's important to clean off any flux residue here too. A quick wipe with isopropyl alcohol will do the job. Connect the D1 Mini to the computer and let's move to Home Assistant. We go to Add-ons and look for ESPHome Device Builder. We install it, and before starting the add-on, we make sure to check Watchdog and Show in Sidebar. Once it's installed and started, we can open it. Next, go to Secrets, add your Wi-Fi credentials, and don't forget to save the changes. Let's add a new device by clicking the green button at the bottom right. Continue and give it a name. Select ESP8266 as the board, press Install, and choose the option Plug into this computer. This will create a .bin file that we can flash to our ESP board. Once that's done, we download the project and open ESPHome Web. We click on Connect, select our device from the list, and install the project. Since we didn't write any code yet, the only thing it will do is connect to Wi-Fi using the credentials we saved earlier in Secrets. After this, if we go to ESPHome Web Device Builder in Home Assistant, we can see that our device has successfully connected to Wi-Fi and is now online. You can leave the USB cable connected for debugging with ESPHome web to see the logs in real time, but I wouldn't connect the 3.3 volts power from the dehumidifier at the same time, since I'm not sure if it's safe to use an external 3.3 volt source while the USB is connected. To be safe, and because I don't need debugging right now, I will just disconnect the USB cable and power the D1 Mini from the dehumidifier's 3.3 volts line. If you know more about this, let me know in the comments. The yellow wire from the power button goes into D1, the orange wire from the mod button into D2, and the purple wire from the light button into D3. The brown wire goes into D5, and no, I didn't forget about it. I will explain later why it's here. For power, the blue wire goes into ground, and the red wire goes into 3.3 volts on the ESP. Here is a closer view. Now that everything is connected, let's go back to ESPHome device builder and edit the code. My board is not ESP01, so I change it to D1 Mini. Okay, first thing, we declare 3 outputs under output. That way, we are telling the ESP what's connected where. Basically, D1 is for the power button, D2 is for the mod button, and D3 is for the light button. In my case, I added inverted logic. This makes the buttons work correctly on my dehumidifier. But on other devices, you might not need to invert the logic at all. Now let's create a power button. When pressed, it will send a low signal and then a high signal to the power pin. This is simulating a tap on the dehumidifier's power button. We can save and install the new code, this time wirelessly. Since it's the first time, it may take a while because ESPHome needs to compile all the necessary files for the firmware. Just wait until you see the purple text. That's the debug log from the ESP, which means it successfully booted up. Next, we go to Device and Services in Home Assistant. Here we can see that it automatically discovered our ESP device. We can add it directly by pressing Add, or go to ESPHome and do it from there. Once the device is added in ESPHome, we can open it to see the controls. For now, we have only the power button. After pressing it, the dehumidifier turned on, so it's working. Now let's press it again to turn it off. With the dehumidifier off, let's check the brown wire. I turn on the multimeter and set it to DC voltage mode. Then place the black probe on the ground and the red probe on the brown wire. Make sure to hold the probe for a second or two. That way we are sure we read the correct value. We read no voltage. Now I turn on the dehumidifier and measure again. I hold it for a second, and this time we get 3.3 volts. So no voltage when the device is off and 3.3 volts when it's on. Based on this, we can use the brown wire to read the state of the device. Now let's turn off the device and go back to the code to add the binary sensor. Like we measured a moment ago, 0 volts with the dehumidifier off and 3.3 volts when it was on. This binary sensor handles that automatically and sends the result to Home Assistant. Next, let's create a script to turn off the LEDs. At the beginning, I showed you that pressing the light button twice turns them off. This script will simulate that. Just like with the power button, one tap is a high signal followed by a low signal. And here we simply run that sequence twice with a short delay in between. Scripts won't run automatically, so we need to trigger them. Let's run this one when the power button is pressed, but with a small check first to make sure the dehumidifier is on. Otherwise, trying to turn off the LEDs while the device is off wouldn't make sense. Now it's time to save and install the new code and test everything we added. The state is off because the device is off, and after we press the power button, we can see the LEDs turn off and the state change to on. We turn the device off and the state updates to off. So everything works as planned. Now let's go back to the code and add some new features. First, I will make a small change to the name of the binary sensor. That's just a personal preference. We add 2 new scripts. The first script will simulate a tap on the mode button. When the dehumidifier powers on, the mode is always set to default, and by simulating a single tap on the mode button, we can switch it to night mode. The second script simulates 2 taps on the mode button. This will switch the mode back to default. Between night and default, there is a mode called auto, which I won't be using because I don't trust the internal humidity sensor. Later, I will show you another issue with this mode. To run these scripts, we will add a select control with 2 options, default and night. When we switch between them, ESPHome runs the right script to press the mode button, but only if the device is on. As usual, I saved and installed the new code. Now let's test the changes. We turn on the dehumidifier and change the mode to night. The command is received correctly, but we also notice a problem. The state changes from on to off and back, even though we didn't press the power button. To understand why, let's measure the brown wire with the multimeter. Instead of 3.3 volts, we only get 2.6. This 2.6 volts is exactly at the minimum voltage that ESP reads as high, so the signal fluctuates between high and low, which explains why the state changes unexpectedly. I have a quick fix for this, but let's continue testing. We turn off the dehumidifier and the last mode selected is night. Turning it back on, it always starts in default mode. But the ESP still thinks it's night mode. If we switch to default, the ESP simulates 2 taps on the mode button, which actually sends the dehumidifier to auto. This makes the state show off, even though the device is running. Measuring the brown wire, we see 0 volts, because the device is in standby. In auto mode, the dehumidifier only starts above 50% humidity, but the internal sensor reads lower values than the actual level, leaving the device in standby, which is why I avoid this mode. Now we can turn off the device and go back to the code to fix these issues. To fix the flickering state, we add a filter to the binary sensor. This filter waits 100 milliseconds before moving the state to off. If the signal quickly comes back, it ignores the drop, keeping the state stable. To prevent potential issues, on boot we can check the dehumidifier state and if it's on, turn it off. This way, the dehumidifier and the ESP will stay in sync. On top of that, we can run a script to ensure the select always starts on default position. Let's create the script mode default. Like I said, it just moved the select to default position. Now we can modify a bit the power button. After sending the power off signal, it checks the select position and moves it to default if needed. Now let's do the same check, but before sending the power on signal. This way, all situations are covered, and the ESP and dehumidifier stays perfectly in sync, but we can't be sure till we try it, so let's do it. We power it on and change the mode to night. The state remains stable, which is good. When we turn it off, we can see the drop-down moves back to default. If we accidentally set the mode to night, powering the device on automatically set it to default, keeping it in sync with the dehumidifier. To test everything, I created a custom button. I turned on the device, selected night mode, then turn it off. The select moved to default just like we expected. Even if I selected night while the device was off and then powered it on, the select switched to default to stay in sync. But just when I thought everything was fine, I selected default again, even though it was already selected. And this happened. Yes, the dehumidifier somehow switched to auto mode. Looks like this is a little bug with the select in bubble card. I already let the developer know and he said he will check it out. Until then, we can easily fix it by comparing the current mode with the previous mode before running any action. So let's change the code. But first, it shows an error because we used the variable last mode before declaring it. So let's declare it. And one more change. In the script mode default, we need to update the last mode variable every time the script is executed. Now let's save and install the code one last time. Before reassembling, I secured the jumper wires with hot glue so they stay in place. Now let's move on to the reassembly. Now that it's all back together, let's test it out and see how it works, but this time from the phone. Only for this video, I also created a button to control the LEDs. Let's turn the device on, switch the mode to night, and back to default. Pressing the LED button turns the LEDs on and automatically cycles through the colors. Pressing it again locks the color, and one more tap turns the LEDs off. Now let's turn the device off. And that's it, we just made a regular device smart with a simple ESP8266 and a bit of YAML code. If you found this useful, consider liking the video and subscribing for more Home Assistant projects. Thanks for watching and see you in the next one.